Okay, so we're going to get into some more factoring here. But first we have some multiplying. And the reason we're doing that is just to kind of prove a point here. So we can multiply this. X times x is x squared. I'll zoom in here a little bit more. X times negative 3 is a negative 3x. Negative 3x times x is a positive 3x. And then 3 times negative 3 is a negative 9. Now, these are alike, so negative 3 plus positive 3 cancel out. And so you're left with an x squared minus 9. Okay. Let's try another one here. So 2x times 2x is a 4, and then there's 2 x's, so an x squared. And then I have a 2x times negative 3. So that's a negative 6x. And then 3 times 2 is a positive 6 with an x. And then 3 times negative 3 is a negative 9. So this leaves me with a 4x squared. These are alike. Negative 6 plus positive 6 cancel out. There's the same number. One's positive, one's negative. So those are gone, and you just have a 4x squared minus 9. Okay, let's try another one here. 2x times 2x is going to be a 4, and x and x is x squared. 2x times negative 3y, so 2 times 3 is negative 6, and there's an x and a y. And then here, 3 times 2 is also a 6, but positive, and there's an x and a y. And lastly, 3 times negative 3 is a negative 9, and then there's 2 y's, so a y squared. Now, these are alike, negative 6 and positive 6. There's the same number of x, y's, so those can cancel. There's 0. 4x squared minus 9y squared. So the idea here is to take a look at all of these. And we are going to start with this. And the idea is, can we factor it? And so when we look at trinomials have 3 terms. But this has 2 because, well, these ones ended up canceling out. And, well, same with these. Those middle ones ended up canceling out. And, well, these middle ones ended up canceling out. So often when we were doing our diagonals, when we would do our factoring, and I would check the left and check the right diagonals, I would see if it adds up to the middle term. But here, the middle terms between the 4x squared and the 9x, the middle term is actually missing. So it can kind of be written like this, 0x minus 9, where negative 6 plus 6 was 0. And so we just cancel them out. We don't write it. But when we check our diagonals, we're going to notice that even though this has only 2 terms, it's not a trinomial. I think the title of this thing is, this is called factoring, but we're factoring trinomials, which means 3 terms. Well, this only has 2, but we have to remember that actually there was this middle term at some point, but it's been eliminated because it was 0 and there was really no need to write it. But the answer is it can be factored because, well, we started with the factored form. So when we had it, so we started with the factored form and we multiplied it. So now what we want to do is start with this, and can we turn it back into factored form? So I realize I just drew a lot of things, but you will understand, I think, as we do some video or do some questions here, what I mean by that. So the only thing that's worth noting in all of these is, well, there's a 1x, and a 3, 3. These 2 things are identical, except the inside has a plus and this one has a minus. And then that resulted in the middle term canceling. If you look at this one, 2x plus 3, 2x minus 3. Same terms, but one's a plus, one's a minus. And in the end, these things ended up canceling. Look over here, 2x, 3y, 2x, 3y, same terms. One's a positive, one's a negative in the middle. And that ended up with these things canceling. So we just should keep that in mind. So we would try to factor this. And what I like about this is that we're factoring the exact same way. the left side needs to multiply to the left. So x times x equals 16. The right side, well, the middle thing is actually gone, so 16 is the right. So we can do 4 and 4, we can do 8 and 2, we can do 16 and 1. There's a bunch of different options. But we should realize, well, hey, the middle term is gone. It would be a 0. And you need to know, well, the only way we got these things where these zeros happened was if these things were identical. Like here, this was identical. 2x, 2x, 3 and 3. They were identical, and that resulted in this thing, the middle term, canceling out. Now, it wasn't just identical. It was a positive and a 1 and a negative. So I'm not going to try an 8 and a 2. I want to keep them identical. I want to try a 4 and a 4. But I want to make one of them positive and one of them negative. So now if I do my diagonals, we're going to do a few examples here. So just stick with me. When we do our diagonals, you get x times 4, which is a 4x. This right here is a negative 4x. Negative 4 and positive 4 is a 0x. Sure enough, I do have 0 x's. I didn't even bother writing it. So that's my answer here. X plus 4 and x minus 4. So you notice x and 4, same numbers, same letters. It's just that the symbol on the inside has changed. And that works perfect for us because when we do our diagonals, we end up getting 0. But let's just keep trying more because it just takes a few examples for you to see the pattern. So 9 is going to be 3 and 3, x and x. It could be 9 and 1, but again, I notice that the middle is missing. When I notice the middle is missing, I'm like, oh, things had to cancel. And the only way for things to cancel is if they're the same. So 25 could be 25 and 1, but I need them to be the same. Now make one, I usually make the top positive, the bottom negative, and then I'll just double check. So that's going to be a negative 15x. Here's a positive 15x. Sure enough, if I added those, I would get a 0x, and I am missing my term. It was a 0. So that's perfect. And the left side multiplies to the left. 9. Negative 5 times positive 5 is negative 25. So there's my answer, 3x plus 5 and a 3x minus 5. Let's try another one here. Okay. So I noticed, oh, the middle term is gone. There's an x squared. There's a y squared. So in the middle, there must have been just an xy. It probably would have said 25x squared plus 0xy minus 36y squared. So that's what it would have said, and then we just would have canceled that out. So this will be a 5 and an x and an x. 36 could be 12 and 3, but I'm going to make them 6 and 6 because I want them the same, y and y. And one of them negative, the other one positive, so that this is still multiplies to be negative 36 y squared, and this multiplies to be 5 x, or 5 times 5 is 25 x squared. And my diagonals here are going to be a 30 xy and a negative 30 xy, which result in a 0 xy, which is what I have. I have 0 xy's. So there's my answer, 5x, 6y, 5x minus 6y. So a 5x plus 6y, and then a 5x minus 6y. Okay. Now I noticed my brackets had disappeared. They were here at some point. I'll zoom out here, and then the next video we'll do the next questions.